This video will show you how to calculate the confidence interval of a population average for both a large and a small population. So let's start by looking at a large population. In this case, we're looking at dairy cows, where the treatment is feeding a specific diet and the outcome of interest is the average milk solids per cow measured on average over a 300-day lactation. So let's say that we have 140 animals in our population. The milk solids produced by each cow in their 300-day lactation was measured, and the average was 502 kilograms of milk solids per cow. The standard deviation was 80 kilograms of milk solids. So we want to know what is the 95% confidence interval for the population average in this population. So we can go to our formulas for calculating confidence intervals. And we know the confidence interval for the mean depends on the mean value itself, the standard deviation, and the number of animals in the population. The formula being, for the upper, the formula is mean plus t times the standard deviation over the square root of number of animals in the trial. And for the lower, it's going to be the same, except instead of plus, it's a minus. Now, of course, Excel's not going to like it when we put this formula in like this. So we can now replace the words in this formula with the cells where that data is. So the mean is 502. The standard deviation, delete, is 80. And the square root of the number of animals, well, the number is 140. SQRT is the Excel function to find the square root. And if we press enter, of course that's still not going to like it. Number one, because we've got our units in our cells here, and Excel wants to see this as a numerical if it's going to put it into the formula. So we'll get rid of those. So it's getting happier, but we've still got this thing called t that we haven't put in a value for. T, of course, does have a value, and t is dependent on what confidence interval you want. And because we want the 95% confidence interval, we want to find the critical value from the distribution. Now, because we've got more than 30 cows in our sample, instead of using the t value, we can actually use the z value, which is a little bit easier. I'm going to insert an extra row here so that I can put in that value of z, and to return the critical value from the z distribution for a 95% confidence interval, we want the absolute value of the inverse of the normal cumulative distribution, 0.025, because that's the tail of our confidence interval, with a mean of 0 and a standard deviation of 1. And that gives us 1.959964. Often we do use the approximation of 1.96 for the value of z for a 95% confidence interval. Instead of having t here, we can put in the cell reference to that number, and instead of having an x, we're going to use the star, and we've now returned a value. If we use absolute cell referencing, so taking each of these in turn and pressing F4, then we can copy, Control-C, and paste, Control-V, that down into the row below without losing the cell references. Then all we need to do is change our plus sign into a minus sign, and that will give us the lower confidence interval. So that's all very well and good if you've got lots of animals in the population. But what about if we've got less animals? So if we copy these cells, we'll repeat them over here, but now say, for example, that we've only got 20 animals sampled, so n is now 20. The same results are returned with a mean of 502 and a standard deviation of 80, and again we want to calculate the 95% confidence interval. Now, because n is reduced, we can no longer use the z value, and therefore we need to go back to our t distribution, look at how to get the value of t that's appropriate for a 95% confidence interval. The formula for that in Excel is the absolute value of the t inverse function with 0.05 and the number in your sample minus 1. That's your degrees of freedom. We've now got our value of t. Then we can calculate our confidence interval. So we'll calculate the upper, and then we'll do the lower, equals, so the formula says we want the mean, plus, in brackets, t times the standard deviation over the square root of the number in the sample. Make sure that you close all of your brackets properly, and that gives us our upper confidence interval. Again, if we go through and use absolute cell referencing to make sure that these cells aren't going to move, then we can copy and paste that formula into the cell below, replace our plus with a minus, and that will now give us our lower 95% confidence interval. And it's interesting to compare the two and see what effect your sample size has had on the width of your confidence intervals.